so when we talk about decimals, who can give me a definition of a decimal? What's a good definition? Hello?
Numbers that represent a part of all.
Mm-hmm. Decimals and fractions are exactly the same thing. They represent part of a whole. It's just that they're in different formats. And so when we start studying fractions, this is going to be kind of familiar to you because we would have studied decimals. So the only difference between decimals and fractions is that they are in a different format. Now here's an example of a decimal. In words, we have 4 and 7/10, which would look like this in standard form, 4.7. Now, just like with whole numbers, decimal place values are very important. A decimal is a number with a decimal point in it, and it represents part of a whole. Some examples are 6 and 52/100, 5/10, and 1/100. The values of the digits in decimals is based on the number 10, or the base of 10, just like in whole numbers. The digits to the left of the decimal place represent the whole number, and numbers to the right of the decimal point represent some part of 1. That's where your part of a whole comes. It's on the right side of your standard form. Now, here's an example of some place values. You see that you've got the decimal point here, and if you're going to write it in words or read it out loud, you would say and. A lot of students will just use the word point, but this is and. So we have 45 and 209 thousandths. That's how we would read this. On this number here, we start with 2,164 and 578 thousandths. You read the very last decimal place. Now, I believe I gave you guys a chart in your packet. So if you will turn to page 2, you will see that you have a chart to help you read these numbers. I put one on page 2 and on page 3. So what I really want to do today is I want you to read, write, say out loud, find the place values, and do some ordering, some comparing, and some rounding with decimals today. And then we'll start with the operations tomorrow.
You'll be your best friend today, Ms. D.
You'll be what?
You'll be your best friend today. This is like a whole bunch of numbers on this paper scrambled up.
All right, so pay special attention and then Jacobia so you can read it right, okay? All right, so let's write some place values down. So starting at the decimal point, remember every whole number has a decimal to the right of it, whether you see it there or not. And one of the things you can do with your mind to make sure your mind knows that decimal is there is just think of a whole number in terms of dollars and cents. Then you will understand that there's a decimal to the right of every whole number. So we have already studied the ones, the tens, the hundreds, the thousands, and so on when we were working with whole numbers. But I want to focus on those place values to the right of the decimal. Notice the first place value is not a ones or a units, it's the tenths. Every place value will go by 10. So we have the tenths, the hundreds, the thousands. What's after thousands? 10,000s, 100,000s, and then millions. Just like over on the other side of the whole numbers, after we have thousands, we have 10,000, 100,000, a million, okay? So it's just to the right. But notice, when we start out on our decimals, we start with the tenths place. Now, if I put in a number, here I have 717. I don't have any numbers to the right of the decimal place, so I can just read this as a whole number. This is in standard form, and this is in word form. When you're just writing a whole number, you don't use the word and. And is only reserved for the decimal place itself. So 717 is this number in words. So the different forms will be word form, expanded form, standard form. You need to know how to write all of those forms. This is also a whole number because it ends prior to the decimal, and we would read this as 4,805. Now remember, every 3 spaces to the left, you're going to put a comma. That's called a period. So for every period, we're going to put a comma. And it just helps us read the numbers better, especially when they get really big, right? So putting those commas in there will help you with the reading, okay? So you guys read this one to me, that part of it.
2,973.
Okay, 2,973. Then if I put an 8 there. Now how would I read this entire number? 2,973 and 865 thousandths. You read that very last decimal place. And let's put that in words. You want to put a comma after 2,000 because it's separating the 3 periods there. So 2,973. Anytime you have 20, 30, 40, 50, 60, 70, 80, or 90, and another digit, you put a dash between the 2 numbers. 73. So if this was 92, you would say 90-2. And 865. We also did it for 65 because it's 60 and then 5. Thousands is the very last place value, so you say that last, okay? Let's try another one. So how would I read this one?
523 and 100.
What did you say? 800? I thought I heard somebody say 800. 189 thousandths, yes, not 800. So this is what it looks like in words. So the 23 has a dash and the 89 has a dash. Okay, tell me how I would read this one. Now remember, adults have troubles with 0, so make sure that you take care of your 0 correctly here. So how would I read this?
601, 79.
Good. 601 and 79 hundredths. Now what about this one with all these zeros?
7,009 and 24,000.
Good. Good, good, good. Don't let all those zeros make you crazy. So 7,009, and I still put a comma where there's 7,000, even though I'm just going to have a 9. And 24 thousandths. Now, how am I going to read all these zeros? How would I read it? 15 what?
Thousands.
15,000.
No, what kind of thousands?
15.
10,000s, yes. 15 10,000s. Now, a strategy for writing this, if I was given the words instead of the numbers, is I would go ahead and put a decimal, and then I like to do these underlines and just count out tenths, hundreds, thousands, 10,000s. I know the last digit has to be in the 10,000s place. So I would have put the 5 here, the 1 here, and then I know I have to fill in zeros. Now, I have a 0 in the ones place just to show that this really is a decimal. Now, this is kind of important. In math, you don't really have to have this lead 0, but in my class, you do. I don't want to be guessing whether you're writing a decimal or not, okay? I want you to put a 0 in the ones place if you are talking about just a decimal. So you're warning me by telling me, hey, this is going to be a decimal. And a lot of you, if you ever go into the medical field or even in accounting, doing any basic accounting, if you don't have that lead 0 with the decimal, sometimes people will misread your numbers and your financial reports will be messed up, or you can overdose somebody in a dosage. Even at Children's Hospital, a couple of kids got murdered basically because their medication was too much, because the person writing down the medication did not write it down properly, and they were overdosed by the nurse. So if you need to have a lead 0, put one there. I even have a nightmare. I used to work for IBM, and we were on the Nordstrom's team, and there was a lead administrator, and then there was me helping her, and she had to hand type an invoice for Nordstrom's to pay for one of their 3090s, which is a huge computer. And she sent them a hand-typed invoice for $30,000. Well, in the 80s and 90s, a 3090 did not cost $30,000. They cost $300,000 because she had forgot a 0. Of course, Nordstrom's paid that bill right away. As soon as they saw it, they paid the $30,000 right away. And it wasn't until the marketing people who get paid on that money, they said, wait a minute, why is this just $30,000? Because that's a different kind of check compared to a $300,000 check. And when she looked at it, she goes, oh my God, I forgot a 0. And she and the marketing team and the branch manager and all these people had to go over to Nordstrom's and say, hey, by the way, you owe us for $300,000, not $30,000. And that was not a fun conversation. So what do you think Nordstrom's did? They're a pretty good company. They paid the bill right away. They knew it was they knew it was fishy, but they're like, okay, we'll pay this bill, but I don't know. So I didn't think we got that much of a discount. So zeros do matter. Reading and writing your numbers do matter and can affect people. It affects their pay, it affects people's businesses, and if you're in the medical field, it can be life or death. So you need to do this properly and learn how to do it and keep it in your memory of how to do it, okay? Sometimes we forget if we don't use it. How would I read this one? Oh, I'm sorry. I went too fast. But you guys can read it for me. 3,000 thousandths. And I want to hear that "s" on the end, okay? Don't get lazy. Because the "s" tells me that you're talking about a decimal. Now, let's go from words to standard form. How would I write this number? How would I write it? In the tens place, I would have a.
2.
In the ones place, I would have a. Would I have anything else? No, I don't need it. Not for 29, right? Now, I could write 29.0, but the zero is not necessary. And I could go 29.00. Those 2 zeros are not necessary. What is necessary is the 2 and the 9. What about this number? How would I write it?
694.
694. What about this one? How would I write it? 1,
5.
5, and
127.
0.27, okay? What about this one?
30.
3, 0.
27.
Hello?
207.
No, not 207, not 2007. 0, 2, 7. Remember, the 7 has got to be in that very last place value. So you might want to just put a line for tens, a line for hundreds, and a line for thousands, and then put that digit here and go backwards up to the decimal. That's a strategy. How would I write this one? 7 what? 706, good. 143. So be careful of those zeros. That's where a lot of people get in trouble. It's not putting their zeros correct. Okay, what about this one? No, not 800.
834.
834. 24, okay. How would I write this one? 0.4. I want that 0 there, okay? I want you guys to practice putting that 0 there. Okay, what about this one?
0.
Okay, so 0, 2, no,
1 6.
1 6. You guys are forgetting your 1. Okay, it's 16 thousandths. All right, now to write a decimal as a fraction, you need to write the fraction as you would say the decimal. So a lot of people forget this. Now, how would I read this number?
100.
Is it 100? How would I write or say this number?
1200.
Not 1200. Imagine putting a comma here. 12,345. What? Is that 10 thousandths? I would count it. Tenths, hundreds, thousands, 10 thousandths, 100 thousandths. Right? That's the first thing I would have done is count the place values so I know what it's going to end with. Okay? This is 5 tenths. What's this?
6,800.
68 hundredths. Okay.
12,000.
12 thousandths.
99.
99 hundredths.
473,000.
473 thousandths. And these are the ways that you would write these as fractions. You said that this was 5/10ths, so write it as 5/10 initially. In fractions, we know we need to reduce, but initially just write what you say. For 68 hundredths, we just wrote 68/100. For 12 thousandths, just write 12/1000. For 99 hundredths, just write 99/100. And for 473 thousandths, we'll just put 473 and then 1,000. Some of these fractions can be reduced further. That means that I can take a common factor, top and bottom, and reduce it. For 5/10ths, what number do they have in common that I can reduce by? What number will go into both 5 and 10 evenly? 2 doesn't go into 5 evenly. What about 5? How many times does 5 go into 5? Once. How many times does 5 go into 10? 2 times. So this is the same as going to say 1/2 there. I'm going to go to the simplifying right now. Remember that 6/10ths is the same as 6/10. But we know that 2 can go into both 6 and 10. So you need to simplify it and reduce it. 2 goes into 6 3 times, and 2 goes into 10 5 times. So if you can reduce your fraction, you should. Anytime you see the word simplify, reduce, that means to reduce it by the same number that will go into both the top and the bottom. So let's just do a little bit of this. When we get to fractions, we'll do a whole lot more of those. So let's go back to our original. Here we said 5 will go. So 5 goes once, 5 goes twice, we'll get 1/2. What did I use to reduce 68 and 100 to get these? What number did I reduce by? 4. Okay. And then for 12/1000, what number did I use to reduce this? To get this? 4. Again, 4 goes into 12 3 times. 4 goes into 1,000 250 times. I can't reduce 99/100, and I cannot reduce 473/1000 because there's no number that goes into both of them evenly other than 1. And 1 is not going to be significant because you'll get the same number. Okay? So sometimes you can reduce it and sometimes you can't. You just have to do that little test. Now, let's talk about how to go from fractions to decimals. You can write a fraction as a decimal by dividing the numerator by the denominator. The denominator is your divisor. The numerator is your dividend. So, remember the fraction symbol means division. So if I had 3/4, I would divide 4 into 3. All I have to do is say, hey, 4 cannot go into 3, so I'm going to put a 0 above it. I'm going to write the decimal that's actually there, bring it up into the quotient, and I'm going to add a 0. Then I go 4 into 30 goes 7 times. 7 times 4 is 28. 28 minus 28 from 30 is 2. And then I bring down a 0. 4 goes into 25 times. So my decimal that's equivalent to the fraction 3/4 is 0.75. So you'll just divide it. One more thing. When you divide, remember, add zeros to finish out your division. And two things will happen. You're going to get what's called a terminating decimal. A terminating decimal stops. So if I were to take 2/5 and I divide 5 into 2, I put my decimal up here and I start putting a 0 down. 5 goes into 20 4 times. It stops. I have nothing else to bring down. Or I could get a problem like this, where I have 2/6. And when I divide 6 into 2 and I add my zeros and I start dividing, I keep getting 0.33333. All of those digits indicates that I have what's called a repeating decimal. It doesn't stop. So there's a couple of different ways I can handle that. I could write that as, 0.3 with a line over it, or 0.3 and a third. Now 0.3 and a third is called a decimal fraction. Another word for decimals is decimal fraction. Because a decimal does represent part of a whole. It is like a fraction. Here's some examples of repeating decimals. Sometimes your repeating decimals can be 1 digit, they can be 2 digits, or they can be 3 digits that keep repeating over and over and over again. So it could be a group of numbers that repeat. You just need to look for the pattern. Once you find the pattern, just put a line over it. This will be in decimal form. Or like I said, you can write it as a decimal fraction. Because you don't want to sit there and keep dividing and dividing forever. That goes on forever like that. So if I have a mixed number, whatever the whole number is in the mixed number, which is a fraction, will also be the same whole number in the decimal. So here we have 1 and 2/5. Here we have 1 and 4/10. These are equivalent. 1 and 2/10 is the same as 1 and 2/10. I can reduce by 2 and I get 1 and 1/5. Remember, if you have a fraction that can be reduced, go ahead and reduce it. Remember also, the whole number in a fraction stays a whole number in the decimal form as well. I want you guys to write these problems down and solve them. The first set here in the exercises, we want you to just tell me what the place value is of the underlying digit. Just name that place value. On the second set of questions, I want to know what number does the underlying name. Tell me the number. And then on the next set, you've got 2 numbers up and down that are grouped. And which of the 3 has the greatest value? Okay, so tell me which one has the greatest value in this set. It looks like I did 4 of them instead of 3. So which of this set of 4, circle the one, top and bottom, that has the greatest value? And I'll give you guys a few minutes to do those exercises. You can do them together as a group if you like. You can group with a table mate if you like. You mean on the bottom here? Yeah, which of these has the 3 that has a greater value? So here my 3 is here, and here my 3 is here. So which one is the greatest value for the 3? So you should circle this one, because this 3 is in the ones place, but this 3 is in the tens place. So this is like $3 compared to 30 cents. So this one is larger. So you'll circle the top one. So do you guys get it? What about this second one? The 3 is in the hundredths place here, which is like a penny. And this 3 is in the thousands place, which isn't even a penny yet. So the top one is larger. Okay? Let me know when you guys are finished. Okay, so what's the place value of the 6? And the 0? Tens. And 6? Hundreds. 6? Tens. 6? Thousands. And 5? Ones. Okay, what number does the underline name? This is 3 what? 3 hundredths. What about this one? 9 tenths. I want the whole number. And then this one? No, 20. Okay. And then this one? 9 thousandths. And then 3 thousandths. So I already told you this 3 is bigger here, and this 3 is bigger here. What about this set? Which one has the bigger 3? The second one, 1,240.308. This is in the tens place, and this is in the hundreds place. And then what about this last one, last set? 49, the bottom. 49.321, this one has the 3 in the larger place. Okay, try these. I think those are self-explanatory. All done? Okay, so what did you write for this first one? No, not 0, 0.
0.0520.
No. 0 point. Nope.
0.52.
0.0.
This one here?
Oh.
0.609 is what you should have there.
We was on number 2.
No, I'm right here. First one, first row. Hello, we need to do number 1 first before we do number 2. Okay, what about the second one in question number 1? 4.0.
0.089.
Good. 4.089. And then this one should be good. 86.003. What about this one? No, this one here. 0.5. Okay, and then the last one?
2.
Right, 2.125. That's right, Teresa. Okay, now, Jacobia, you were telling me what number 2 was. What is it? 0.052 is correct. What about number 3? 4.004 is correct. And then what about number 4? 0.008 is correct. And the last one? 159.12. Good. I think you guys have it.
I just don't know how to do the fractions.
We're not going to worry about
Right.
We're not going to worry too much about fractions today. There might be just a few conversion of fractions to decimals in your packet, but not too many. Let's talk about another very important subject when it comes to decimals, and that's rounding. We need to order, we need to compare, and we need to round decimals, and we do it automatically all the time anyway. Remember, rounding and estimating are very much the same. Estimating, you just pick a particular place value to round to. So, let's talk about comparing first. What do I mean when I say compare decimals? We did it in that last exercise. Remember where I told you to find the 3 and then tell me which one's larger? That was comparing. You guys have already done it. You do it all the time. You already have that skill. So, when you're comparing, you're using either the less than symbol, the greater than symbol, or the equal to symbol. And you can use it just as quickly as what we did in that exercise. Now, there is a strategy to remember the difference between the symbols for less than and greater than. Anybody got a strategy that they want to share? How do you remember which one's less than and which one's greater than?
I just remember that the open part of the facing toward the that's bigger. That's not
Okay. So if I were to take my hand, let's just do a little bit of air writing. Hold your hands like this for the symbol. Hello? Let me see them. Okay. This open part always is facing the bigger number. So you can think of this as a big old alligator eating the big number. The open part of the symbol is always eating the bigger number. It has to open its mouth wider. Okay? The pointy side is always the small side. Okay? So I learned alligator. How many of you also learned alligator? Okay. When my daughter learned comparing, they told her it was a duck because they thought the alligator was too violent, which I thought was so ridiculous, okay? So, and I remember the alligator because, of course, you don't want to be too in an alligator's mouth, you know? So, duck or alligator, whatever way you learned it is fine, okay? So you want to keep that strategy in mind when you're talking about greater than and less than. Now, there is a really good strategy for remembering or figuring out which number is bigger. Line up all your numbers vertically. That means up and down, like buttons on a shirt or a zipper, up and down. And add zeros to fill in any missing places. Then compare the numbers from left to right. And you can read the numbers and see which one's bigger or which one's smaller. So if I have these numbers, 12 and 5/10, 12 and 24 hundredths, 11 and 96 hundredths, and 12 and 36 hundredths, to use this strategy, I would just line them up. Notice, this has 2 decimal places, this has 2 decimal places, this has 2 decimal places, but the 5 doesn't. So you can put a 0 here because there's nothing next to it and it doesn't change its value. But vertically, they all look like they have the same number of digits. So that's what you want to do so that visually you can tell quickly which numbers need to go in order. So I know that 1196 is less than 1224, which is less than 1236, which is less than 1250, right? It's easy to do. What order did I put these in? Because I didn't tell you what order to put them in. What order did I put them in? What kind of order? Least to greatest. Smallest to largest. But I could also do largest to smallest, right? Excuse me. Something's in my throat. Okay, so now that we know how to compare, we know what the compare symbols are. Now that we know that we can order numbers based on their place value by lining up, that's a strategy we could use. We want to do some rounding. Now this is something you guys do all the time. I'm sure you have a rounding strategy, but I am going to teach you this rhyme for rounding because a lot of people can never explain to me how they round. So I'm just going to give you a strategy. If you don't like my strategy, that's okay. You don't have to use my strategy, but you will need to sing with me today. This strategy has 5 lines, and they're all important. The first line says, find the number. When I say find the number, I mean go find the place value that you need to round to and underline it. And then on the second line it says look right next door. Once you find that place value that you're rounding to, you're going to look to the right. What number is immediately to the right of that number? The number that's next door, I circle. Then I want to see, is the number 4 or is it less than 4? Is it 4 or less? If it's 4 or less, the number that's underlined I'm going to leave alone. However, if the number that I've circled is 5 or more, I'm going to add one more to the number I underlined. And because it's a decimal, I'm going to stop right where I am, and I'm going to knock off all the numbers to the right of that number. So let's just sing this a little bit and then we're going to apply it. Now the way this rhyme goes is, find the number, look right next door, 4 or less, just ignore, 5 or more, add one more. Stop and drop. So I want everybody to sing that with me. Find the number, hello, find the number, look right next door, 4 or less, just ignore, 5 or more, add one more, stop and drop. Hello, somebody get off. Okay, we got to sing it one more time. 1, 2, 3. Find the number, look right next door, 4 or less, just ignore, 5 or more, add one more, stop and drop. Much better. Okay. So if I'm rounding 19 and 642 thousandths to the hundredths place, what number do I find? The 6 is not in the hundredths place. The 4. So I locate the 4 and I underline it. Then what am I supposed to do in the next line? Find the number, look right next door. What's right next door? 2. I need to circle it. Now, I have this 2 circled. I need to compare it. Is it 4 or less? Well, since 2 is 4 or less, I just ignore it. And my answer is going to be 19.64 because I drop it. I'm done. Any questions on that one? Let's do another one where we have to add 1 and we have a bunch of 9s. It changes more than one place value. So I need to find the number. In this problem, what am I rounding to? Tenths. So what number am I going to underline? I have 3 9s there. Which 9 are you talking about? To the left of the decimal?
The right.
The one immediately to the right of the decimal. That's the tenths place. Then I'm going to look right next door. Right next door is another big old 9, right? So find the number, look right next door, 4 or less, just ignore. But my situation is 5 or more. What am I supposed to do when I have 5 or more? Add one more where? Which 9? This one. So if I add one more to this 9 here, I get 9 plus 1. Ooh, 9 plus 1 is 10. So this is going to be a 0 and I carry a 1. So it becomes a math problem. Which I love.
40.
Now, do I need to have that point 0 on the end? Hello?
No.
Hello? By the way, when I say hello, that means rethink what you just said.
Well, no.
Hello?
I don't know.
You need to have the decimal there. Why? Didn't I tell you to round it to the tenths? Well, you need to show me that you rounded to the tenths by putting a 0 there. If you don't put a 0 there, then I don't know you rounded to the tenths. Okay? So you need to put it there in that case. Because then you can say, oh, Miss D, I rounded to the tenths. Let's do some practice. If I round this one to the tens, what would my answer be? Hello?
500.
What'd you say to me? 400 what?
Say 500.
500?
400.
470.
Nope, it's not 470.
80.
500, it's 480, yeah. Tens is a whole number. Hello? Remember, this rhyming verse goes with whole numbers as well as decimals. We did this also with whole numbers way back when, okay? You guys forgot already. Okay, what about this one? Round to the nearest whole number. What would that be? 63? Good. What about rounding this one to the nearest tenth? Nearest tenth. 805 point, no, not 5, 6. 805.6. Because the tens place is right here, we have to look right next door. This increases by 1. What about here, nearest thousand? This is easy. 46,000. Nearest hundred. What? 59,600. Nearest thousandth. What would my answer be? 42.598. That's correct, Teresa. Nearest whole number. 6. Nearest 10,000th. 10,000. How many decimal places is the 10,000th? No, not 6 decimal places. 4. So what would my answer be? 3? What's my answer? What's the full answer here? Rounding to the 10,000ths. 92 point, say it, Benin? 92 point what? Not 80, 89. Because if I go to the 10,000s place and I look right next door, it's a 3. So it doesn't change anything. So everything gets dropped. So I get 92.5989. That's it. I'm done. Go to your pocket and let's talk about what you're going to do today. You guys should be excited. You got the Vice President of the United States coming to campus tomorrow. Okay. In today's packet, you're going to write, read, convert decimals and fractions, order, compare, and round decimals. Your pre-test and post-test will be located in Canvas under this topic, decimal concepts. If you need more instruction, if I was going a little bit too fast and you need additional instruction, I will upload today's video for you to look at. But you can also go to our Moodle class where you logged on and had your ID that I told you to write down, because I don't know what your ID and password is, and go and do Unit 3, Lesson 1, Topics 1 and 2 for decimals and rounding if you want some additional explanation. If you do go there, this is independent study. You don't have to go there if you understand what we studied today already. But if you just want to do some additional study, this is independent work that's optional. If you do go there, you need to look at the 2 presentations, work out the examples, the practice, and the reviews. This is nothing new. This is what I give you for every lesson. Because sometimes when I explain things, you might get it right away, and then sometimes when other people explain things, you might get it. So either way is okay. You can listen to both if you like. You're going to check off this study guide once you have completed all of the problems and checked your answer in your answer key that says ABE Math there. So after you've checked it, then you can check this off. Tomorrow, when I do book check, that's when I will give you the 5 points of credit for completing this and all the other assignments in your portfolio that are totally done. You do not get the 5 points until I do that book check on Thursday. Okay, you'll notice that you guys got a lot of 5 points that aren't there yet. So I will give those to you tomorrow. Don't forget to do the post test. Now, what percent do you need to get on the pre and the post test on average for Miss D to be happy? 80% for most of you guys. Those of the people that were in Glenda's class have to get 90, okay? If you did go get the GED textbook, even though it was optional, you don't have to do it, then this same topic is on pages 99 through 102, and you can do the problems there and check the answers there. Because some of you are GED bound and want that extra practice. That's okay. I think I give you plenty of practice though. Page 2. What are you supposed to do on this first exercise? You guys tell me. What you supposed to do?
There's one of these every day.
Yeah. Oh, there's one every day. Yes. Hello. What am I doing on practice 8? What is it we're supposed to do here?
Write them in words.
Yeah, and they better be right. Spelling counts. So if you didn't spell it right, that means you got it wrong as well. So you need to spell thousandth right. A couple of words that people misspell all the time is, how do you spell 40? F-O-R-T-Y. That's always misspelled for some reason. Sometimes people put U in there. And then how do you spell 90? N-I-N-E-T-Y. There's an E there. It's not nitty, it's 90. Okay? How do you spell 100? H-U-N-D-R-E-D. People misspell 100 all the time. Okay? So watch out for these ones that people misspell. Be sure to write it correctly, spell it correctly, and put your commas and your dashes in there if necessary. Okay, on page 3, at the top, you're going to write the numbers that are in words. You're going to put them in standard form, our standard number form. So when you see standard form, you want to always remember that's the number. Okay, on practice C, you're going to tell me what the place value is. So like for instance, I didn't do any examples in this one for you, but in 55.237, the 3 is in what place value? Hundreds. And be sure to spell it right. Hundreds. On question number 6, what is the numeral for 6 hundredths? Is it A, B, C, or D? B. 6 hundredths. Okay, so that page should be pretty easy to do. You guys can finish the rest. On page 4, practice set D. You have a variety of questions regarding place value. In the number 5.3, what place is the 3 in? And that's the tenths. Number 10, it says 0.7 is 7, and you'll write tenths. Just finish that out. let's see, on the next set, we're going to be comparing decimals. For number 1, what symbol should I have? Less than, greater than, or equal to when I read from left to right. You always read left, right, left, right, left, right. So I have 0.33. I need to put the symbol in, and then 0.25. I should put a 0 in front of that. So what should that be? Less than, greater than, or equal to? Greater than. 0.33 is greater than 0.25. On number 2, what symbol should I have? Left, right.
Right.
No, less than. 0.41 is less than 0.50, okay? You set those up vertically and then compare them, okay? So you guys can finish that one out. On page 5, you're just going to put the numbers in order. The top part, you're going to rank the numbers from largest to smallest. So the big number would come first. Here, the big number is 1.05. And then you have 0.5. And then you have 0.25. And then you have 0.099. So you're going to go from the largest to the smallest. But then for 7 through 12, you're going to go from smallest to largest. Which one is the smallest of number 7? Yep.
About 5 cents. 6, 7.
So be sure to put them in the correct order. So there's an example there for you for smallest to largest. Smallest to largest and largest to smallest. Be sure to read the instructions so you know which way you need to go. Okay? That takes care of page 5. Now I think Jacovia was really afraid of converting fractions and decimals back and forth. And you do have some exercises to do. Page 6 and page 7 will be some conversions. So you went from 2/5. If I were to take 5 into 2, and I add a decimal here, because I know 5 cannot go into 2, so I'm going to add a 0. Make this a little bit bigger so you guys can see. I'm going to bring my decimal straight up. I know that 5 cannot go into 0, but 5 will go into 20. How many times? 4 times. So my decimal is 0.4. Now on this decimal, just read this decimal out. This is 1 5/10. Write that down. But 1 5/10 can be reduced by 5, which will give me 1 1/2. Now on this one, they gave me the decimal 0.75, which is 75 hundredths. But I can take 75 hundredths and reduce that by 25, which gives me the fraction 3/4. So 75 hundredths is the same as 3/4. Now on this other one here, I have to take 2, but this 8 has to go into the 3. I need to find out what decimal that's going to be. Bring my decimal up. 8 cannot go into 3, but 8 goes into 30 how many times? I can't do 4, I have to do 3, right? 4 is too big. 3 will give me 24 with a 6 left over. I bring down another 0. 8 goes into 60 7 times. 7 times 8 is 56. Bring down the 4. I have to put another 0 to keep going. I don't see a pattern yet. And 8 will go into 40 5 times. And now my division becomes 0, so it terminates. I need to put 0.375 here. So I get 2.375. Here I'm given the fraction 9 hundredths. I can just write that, 0.09. That's 9 hundredths. Read it out loud and do it. On that last one, I'm going to need to divide. So let me make that pretty big so I can divide that bottom part. I know I'm going to have 3 in my decimal, but I have to figure out what the decimal part is. 5/16. Now 16 will not go into 5. So I'm going to put my decimal here, bring a 0 down. How many times will 16 go into 50? 3, that gives me 48. 2 left over, bring down the 2. Okay. 16 goes into 21 time. When I subtract, I get 4, bring down the 0. Then I get 40. How many times will 16 go into 40? 2 times, I get 32. Then I've got an 8. Bring down to 0. And 16 goes into 80. No, isn't it 5? And then I have nothing left over. So this is a terminating decimal. And I have to put 3125 for the decimal. Remember, the whole number for the fraction and the decimal is going to be the same. It's the part that you would need to figure out what the format is. So you take that fraction, divide the bottom into the top. The bottom is your divisor, the top is your dividend, to figure out what part's the decimal. So I've done page 6 for you. When you do page 7, you have those 3 examples, 3 rows of examples to show you how to do it, okay? So let's go to page 8. You guys can finish this page 7 for homework. Page 8, there's some, actually at the bottom of page 7, there's some definitions too that you're going to want to review because I think I gave you a crossword as well. The crossword is on page 8. You guys can work together as a group to figure out the answers to this crossword. Page 9 reviews rounding. And on page 10 and page 11 you have some rounding to do. I want to go to the Yum Yums. You guys go. Let's go to page 12. We've got a few minutes before break time here. Now, remember, on reading Yum Yums, you have to read carefully, focus on the question. We talked about word problems yesterday. You have to gather the necessary information to solve the problem. You have to plan how you're going to solve the problem. On step 4, you actually solve the problem. And then you want to check yourself on step 5. So on number 1, what is the best estimate for the total? $4,650 for the bedroom furniture and $5,245 for the office furniture. Now, when we were doing addition, way back when, probably a couple weeks ago, you had some estimating problems. Estimating sums. So if you didn't do that, you might want to review that. How could I estimate 4,650? What would that round to or estimate to? What would this round to? Well, some people might say 4,700. What about the 5,245? 5,000 what? 200. So what do you get here? Which one would be the best estimate of that? A, B, C, or D?
B.
So you're gonna go through these answers and figure out what the best estimate would be. Now, if you don't feel comfortable estimating, go ahead and read this paragraph I have on how to estimate. If you forgot how to do those sums and those differences that we did a couple of weeks ago, then you're gonna wanna do that. We did it with whole numbers though. But estimating is a very important skill. You have to use it. Okay, page 13 goes over the 5 steps of solving a word problem again. Page 14, you have a couple word problems to do. I think you guys can handle that. Page 15. Notice that page 15 is not optional. You must do all of these internet activities. They're extended practice, but you need to follow instructions. On activity 1, where you're naming decimals, you're going to go to this website, you're going to click on start, you're going to type in the decimal number, and then you're going to check it. You do not stop until you have 20 correct problems. Once you know that 20 of your problems are correct, let's say you have to do 25 of them in order to get 20 that are actually correct. Then you write down your percentage that you got right, and you can stop and go on to the next activity. I cannot stop you. The computer cannot stop you. Please look at the instructions to see how many you need to do and stop yourself. I've had many times where students will be doing these activities and they get 100 of them done. And I said, I don't think I asked you to do 100. And then they look at the instruction, they go, oh man, I was only supposed to do 20 correct. Okay, so follow the instructions. We are going to take a break now. You guys have, you can take a 20-minute break. The answer key is in the binder for those of you that are finished with the packet. And when we come back from break, you guys can ask me whatever questions you have. So let's take 20 minutes.